Welcome to our thought experiment. Today we're diving into a hypothetical scenario. What if a small needle were to travel at the speed of light and collide with Earth? But we're not talking about normal circumstances, we're talking about the mind-bending realm of relativistic speeds. Let's explore the catastrophic consequences and the physics behind it. You see, the universe plays by some pretty interesting rules laid out by none other than Albert Einstein himself. One of those rules, perhaps the most famous, is that nothing can travel faster than the speed of light. But for our thought experiment, let's imagine that we could just for a moment throw that rule out the window. Buckle up, because things are about to get really interesting. So, we've got this needle, right? Just your average everyday needle, maybe an inch or two long, thin as a hair. Nothing special, right? Wrong. You see, at everyday speeds, the kind of speeds we experience here on Earth, the energy of an object is pretty straightforward. It depends on its mass and its velocity. The faster it goes, the more energy it has. The more massive it is, the more energy it has. Makes sense, right? But when you start approaching the speed of light, things get really weird. Einstein's theory of special relativity tells us that the faster an object goes, the more massive it becomes. Okay, so we've got this needle carrying with it more energy than any weapon mankind has ever devised. What happens when it hits Earth? Well, let's just say it wouldn't be pretty. Remember all that kinetic energy we were talking about? That energy has to go somewhere upon impact, and when it does, it's going to be released with an explosive force unlike anything our planet has ever seen. We're not just talking about a big boom and some mushroom clouds here, though there would definitely be those. We're talking about an event that would make the extinction of the dinosaurs look like a walk in the park. The amount of energy released would be on the order of megatons, perhaps even gigatons of TNT. To put that into perspective, the largest nuclear weapon ever detonated, the Tsar Bomba, had a yield of roughly 50 megatons. Now imagine something thousands, maybe millions of times more powerful than that. Let's dive a bit deeper into the physics of what happens at the moment of impact. As our supercharged needle slams into the Earth's atmosphere, it wouldn't just be a matter of it colliding with the ground. The energy released would be so intense that it would interact with the very air itself. Remember how we talked about the needle's mass increasing as it approached the speed of light? Well, that mass wouldn't just disappear upon impact, it would be converted into pure energy, and a lot of it. We're talking about temperatures hotter than the core of the sun, even for a fraction of a second. This would create a blinding flash of light and a fireball that would be visible for thousands of miles. Now, before anyone starts panicking about needles raining down from space at the speed of light, let's take a step back for a moment. Remember how we said that nothing can travel faster than the speed of light? Well, that's not just some arbitrary rule, it's one of the fundamental principles of the universe according to Einstein's theory of relativity. You see, as an object approaches the speed of light, something really strange happens. It doesn't just get harder to make it go faster, it actually requires an infinite amount of energy to reach the speed of light. And since we don't have an infinite amount of energy lying around, it's safe to say that our needle, or any other object with mass for that matter, will never actually reach the speed of light. So, while our thought experiment is a fun way to explore the extreme edges of physics, it's important to remember that it is just that, a thought experiment. The universe has built-in speed limits for a reason. While this scenario is not physically feasible, it's a fascinating thought experiment that highlights the incredible power and limitations of our universe. The concept of a tiny object like a needle carrying such immense destructive potential underscores the mind-boggling energy scales at play in the cosmos. It also serves as a stark reminder of the importance of understanding and respecting the fundamental laws of physics. Einstein's theories have held up to scrutiny for over a century, and while we continue to push the boundaries of our understanding, it's unlikely that we'll be breaking the speed of light anytime soon. Thanks for watching, and don't forget to like, share, and subscribe for more intriguing content.